Hemp fiber is a pretty huge, expansive topic. I'm going to have to make a little series within a series just about hemp fiber to explain all the different aspects of it and, really give you a good overview. But this is just background information about fiber, so you can understand, better understand the importance of my research project and why there's such a huge opportunity in the cultivation of hemp in California. So, hemp fiber, pictured here in a bale, is historically what hemp has most often been utilized for. Really rough and tumble applications like ropes, um, excuse me, canvas, work clothes, sails, those sort of things has been used for throughout the centuries. Now, the popularity of hemp fiber has waxed and waned over the years, or over the millennia, largely because it's, compared to some other natural fibers, relatively difficult to extract and to work with and to refine. A lot of this is just structurally due to the botany of the plant. And from a processing and mechanical perspective, we figured out how to gin and clean cotton 300 years ago. And the hemp decorticator to mechanically separate all of the hemp fibers that you see here from the plant uh, is only about 80 years old. So, really there was a period there from the 1700s, 1800s, etc., where cotton really took off in the global industrial economy and hemp was sort of left behind. But now that technology exists, there's a huge opportunity for hemp to make a resurgence as a fiber. Now, to understand hemp, I think it's important to just go over bast fibers in general. The picture here on the left is flax field. Picture here on the right is canaf. Canaf is in the Malva family, which I find interesting. There's hibiscus, there's okra, there's cotton, and then there's the common cheeseweed as well as canaf that are all in that family that are, relatively common plants or cultivated plants. Now, both of these and hemp all produce bast fibers being the outer bark of the stem, long natural fiber. And from a post harvest industrial processing perspective, canaf, hemp, and flax fibers are all virtually interchangeable. It's said that hemp fibers are a little bit stronger than both of these, but for production purposes, they're sort of the same commodity. Where hemp has the advantages is agronomically. Hemp is more vigorous than canaf, and it's more widely adaptable than flax. You can see here in this picture, this hemp plants are, easily twice as tall as this man, and you can see the front here where the hemp is shedding its leaves. So this here represents the extent to which sunlight can penetrate this canopy. And, since it can't go any lower than this, the hemp plants have started to desiccate and abscise their leaves, which is an interesting phenomenon I'll get back to later on in this video. So, here's a picture of the fiber coming off of the plant. You can imagine how difficult it would be to separate all this by hand. There are old school things from, hundreds of years ago where it would just be sort of like, one of those hand pump handrail carts, but it would be meant for breaking hemp. They're called hemp breakers, and that's how they would break this woody stem here in the center, which is called the hemp hurd. Now, if we were to continue with the tree analog, the outer fiber here would be like the bark of the tree, and then this hurd would be like the pith, the wood. So in trade, it's called the hurd, and this is a very interesting product in of itself. It has a lot of uses. It's considered to be a byproduct, but it's becoming increasingly valuable, especially as we figured out how to manufacture things with cellulose. But that's for a different video, just focused on fiber here. Now, important thing to note from, again, botanical botany perspective is hemp. Cannabis plants in general have what are called axillary buds. This is a picture of a tomato plant. You can see the axillary buds taken off here. Axillary buds are just buds that grow at the axil or armpit of a plant, basically where the leaf connects to, a leaflet connects to the stem. And This tomato plant is growing pretty healthy. It has a lot of sunlight, so its axillary buds are taken off. Cannabis has axillary buds as well, and if you give it enough space, those axillary buds will take off, and you'll grow a monster plant like this. This is a cropping system for growing flower in Northern California. You can see how monstrous these plants are, and each one of these little growth points here is going to put on a flower spike. So this is a very good system for producing cannabis flowers, but if you compare this to a hemp field, they don't even look like they're the same plant anymore. Botanically, they are. In fact, the male flowers that are just starting to come off on the top of these hemp plants could pollinate this plant, but it goes to show just how extreme of a dimorphism there is in the hemp plant, cannabis plant, depending on its environment, what it's exposed to, because here you have nothing but straight stalks. This is ideal for growing that fiber that we saw, and there are no axillary buds coming off of any of these plants because they had to go straight up. And once again, there's that abscising front through the field where the sunlight is no longer penetrating the canopy and the hemp plants are dropping their leaves. So when it comes to comparing something like hemp to cotton, the fabric of our lives, the king of fibers, you see that they're really just completely different plants going through a completely different life cycle, completely different cropping system. Each one of these little cotton balls here represents a seed pod on the cotton plant, because what happens with cotton is, it grows, it flowers, the flowers get pollinated, and then it produces this little ball, a little seed pod. There's a tiny little seed in there, and the actual white fibers that we harvest are filaments in that pod, and those filaments expand and expand and expand, and after thousands and thousands of years of breeding and really scientific breeding in recent years, we've been able to make that seed pod bigger and bigger and bigger. And in the wild, in nature, that seed pod would explode, and then that seed would go out so it could fall somewhere and become another plant. But here, that seed pod just gets stuck inside that ball of cotton, and we've bred that ball of cotton to become bigger. So, you look at it, you see this hemp plant is being harvested just as the male flowers are coming up. There aren't even much of a female flower up here. It's still very much a juvenile plant. It hasn't even, achieved its goal, I guess, of reproducing, whereas this is a completely mature plant. It's so mature that the seed pods have burst open to try and disperse the seed, and the main plant stem is completely desiccated. There's very little very little green material, no green material left. And from a nutrient use perspective, this really puts into perspective how different hemp is from cotton, and different they are in the impact that they make on the environment. See, somebody has already started to harvest this hemp field, and this hemp field here is likely somewhere between 60 and 90 days old. This cotton field is probably 180 days old. Cotton is the longest cropped plant in that we grow agronomically in the United States. So you can get the fiber from hemp in 1/3 to 1/2 of the time as it would take to grow cotton. And additionally, because of the resource load and the use, because cotton has to go through its complete life cycle and develop a flower and put that flower up, and then be pollinated, and then grow a seed, and then grow a whole filament around the seed, and then burst, and then desiccate. Cotton uses many, many more resources. It uses a lot more nutrients. On the other hand, hemp, because it has that shorter life cycle, this hemp field is going to produce about twice as much fiber per acre as this cotton field. And it's not difficult to see that visually. You imagine how much fiber is on the outside of each one of these stalks, and look how much taller this is than this short little cotton field. But the hemp field is also going to use half as much water. So that's a factor of 4 times more efficient at converting water into fiber, hemp is, than cotton. So, and additionally, because hemp doesn't have to go through this whole life cycle, particularly the very vulnerable phase of flowering and then setting a fruit, and then having that fruit mature and grow to a mature pod and then burst, it's not as vulnerable to a number of diseases and pests and you know other different things that can happen as a result of nature. Nature happens. So there's a tremendous number of potential advantages that hemp has over cotton. Water use, nutrient use, soil quality. Because cotton is such a nutrient hog, it tends to deplete the soil. You talk about your time factors. If hemp is only in the field for one half to one third the amount of time, what can you do with that field if you don't have 180 days of cotton? You can put in a green cover crop. You can put in a green manure. You could grow a second crop of hemp. You could grow vegetables, or you could plant a temporary pasture and raise it down with your lambs, and then you have lambs producing wool that you can then mix with your hemp fiber, send to a factory, and make all kinds of other clothing. And then there are issues of sustainability, and we haven't even gotten into the hemp herd. As you can see from this picture, there's very little straw in this cotton field. Really, all you're growing are these tough balls of cotton versus this hemp field. Once you strip off that outer bark layer, you still have that inner woody hemp herd, which is becoming increasingly valuable and has a plethora of uses. So, obviously, as university professionals, it's our job to do the research, to look at the economic analysis, to get some data out there so that farmers who, more often than not, have a business model that relies on taking money out against their farm and, borrowing so that they can put out next year's crop and then sell that crop and get the money back to pay that and, pocket some profit. They don't have to make as much of a huge risk in planting something that's new. But just on the surface, just looking at these factors and then looking at the data that's out there from the FAO, from other reports and other countries where hemp is grown, there's a very compelling case for hemp being a replacement for cotton, potentially displacing some acreage of cotton, or even being planted in a rotational system with cotton to help remediate some of the soil and alleviate some of the nutrient load, because there are big differences between the hemp fiber and the cotton fiber when it comes to post-processing and refining and all that. But that's a topic for a different video. Anyway, this has been, I hope this introduction to hemp fiber has been really helpful, and that this video has been informative. Don't have much else to say. West Coast.